Okay, so picking up where we left off in chapter 7 about finding areas under the normal curve. So we were looking at this Uber example, right, where we were talking about the particular income potential that we had. And so let me see if we go back to... So we're told the average of this normal curve is 1,000. And we're told that there's a standard deviation of 100. And so we're asked about finding the probability of drivers earning different amounts of money. And so the third example that we're going to do, 3 out of 4, is talking about what's the z-value for the income of a driver who earns, what's the percentage, or what's the probability of finding, another way to think about that, a driver who earns between $840 and $120. Sorry, 1,200. Makes way more sense. So the way that we're going to figure this out, well, number one, what are we trying to figure out? We're trying to figure out this whole area under the curve here, right? For this whole range that we have. And so whenever we're finding areas under the curve, right, that really just means we're integrating, but we're not going to be integrating in this class. We're going to be using those Z tables. And honestly, even in other classes, you learn the integration part of it, and then you end up just using the Z tables, right? So the question that we're asked is, what is the probability and the way that we figure that out is a two-step process. Well, it's a little bit more than 2 steps. 1, 2, 3, 4, 5. 5-step process. So the first step that we have is we have to calculate the z-value for the income of the driver who earns $840. And so calculating our z-value, right, we're just getting that normal distribution into a standard normal distribution. So we're going to take whatever that value is, that x, we're going to subtract mu from it, and then we're going to divide by the standard deviation, right? So we know that this formula z is equal to x minus mu over standard deviation. And so we're going to do this in order to calculate our z statistic for this, which ends up being negative 1.60. So we go ahead and label that negative 1.6, and we have a dollar axis here, and we have a z axis right here. Now, when I'm looking up this negative 1.6 in the z table, am I going to find negative values? No, right? So because it's symmetrical, we just find the z value for 1.6. So when we look in table for the 1.6 and then the 0.0, right? And that's going to give us the value that we have here, which is going to be 0.4452. Now, I kind of jumped ahead of myself because this is actually step 2. So this is telling us 0.4452. That's telling us this part of it. Then our third step is we're going to do the z statistic for the 1,200 number. So this gives us z is equal to 1200 minus 1000 divided by 100, which obviously gives us 2.00. Then we look in the z table and we find that the 2.000 entry gives us a value of 0.4772. So again, there's going to be other values, right? There'll be, a value up here for the 1.900. There'll be a value here for the 1.91. So we're just reading the table. We go down the row axis to find the first integer in the 10th place, and then we go to the column axis to find the 100th place. So 2.00 is going to give us 0.4772, and so we can label this whole part 0.4772. And there can't be two number 3s. I swear I've had my coffee today. And then our fifth part is we are just conceptually, so this is where it's easy for us to get stuck, right? So we start to go through this process where we calculate these z-statistics, right? But figuring out conceptually what the heck that z-statistic means and how to use it in the context of solving the particular problem is kind of another step that a lot of students get stuck at, right? Because you're used to just like calculating the z-statistic and using this average and this standard deviation and then looking in the table for it. But then what does it actually mean, right? So each one of these things that we were doing here, right? This is the probability that the weekly income is between 1,000 and 840, right? This is the probability that the weekly income is between 1,000 and 1,200. So when we're asked what's the probability of the weekly income being between 840 and 1,200, this is going to be these two combined. So this is going to be 0.4452 plus 0.4772, which is going to give us 0.9224. And then whenever we do these, right, I mean, number one, we should have done this in step 2 and in step 4, but, we can look at our normal curve that we've drawn and we can figure out, use the sniff test, use the gut check, right? Figure out, does this stink? Does this seem right? Right? And given how much of the curve is highlighted, right? Given how much of the area under the curve is highlighted between 840 and 1,200, it does make sense that, about 92% of the area under the curve is being covered within that range. Similarly, in number 2 and number 4, since those are fairly close to the entire left half and right half, respectively, I would expect those to be closer to 0.5 than not, right? Now, if you calculated the z-statistic and for some reason, even though it's theoretically not possible, let's say you made a mistake transcribing it, right? And instead of writing down 0.4452, you wrote down 0.5452, or something like that, right? Again, you want to use that gut check, that sniff test to be like, wait a second, how can that be more than half of the normal distribution, right? So number one, your values are never going to be greater than 0.5. And number two, you should be able to kind of check visually, does that jive? Does that make sense that that answer is what it is? Questions on this process for finding the area under a normal curve when we're spanning the mean. So when the mean is inside, we end up having to do two different z-statistics on each side of the mean, and then add them back together. So it's a little bit of a decomposition, composition kind of situation. Questions on that?